Good morning. So TLA, that stands for three-letter acronym, right?
Yeah, it's Temporal Logic of Actions. Yeah, developed by Leslie Lamport. I think he started the project in the 90s, or maybe I'm getting confused with when Paxos was invented, because I think that was 98. Oh, and something I didn't know at the time and that I learned while learning some TLA plus is that Leslie Lamport also invented LaTeX, which I did not know, but seems to be more common knowledge to other people than myself. But that's super surprising to me, because when I was, strictly in the world of mathematics, I used LaTeX all the time. I mean, every paper is written in LaTeX, so that was pretty cool to learn that in this context now. Yeah, so we'll look at so we have, so there's
a TLA and TLA plus, right? So
yeah,
and TLA plus is the real language, right? And TLA is...
I'm not clear on the distinction there, but certainly the language that I'm using, which I hesitate to call, okay, so it's not a programming language, right? So there's the distinction between a programming language and a formal specification language. And so TLA plus is the formal specification language. And now that I have said that out loud, that I'm not clear on the distinction, I think I might be clear on the distinction. And I think TLA is just the specification. Then there's also TLC, which is the model checker that can, model check the specification. And then there's a TLA proof system, which they call TLAPS. And the model checker, the formal specification language, the proof system are all built into TLA plus. I think that's what the plus is all about.
Okay. I remember something from interview of Leslie Lamport. He was talking about difference, how he didn't want to include a lot of stuff in TLA plus.
Yeah. I have pretty limited exposure to it, but I feel like they did a really good job. There's kind of a lot of modularity there too, and I want to show you this because to me it was really cool, but it'll probably just be like, oh yeah, of course you should be able to do that for everybody else, but I'll show you anyways.
Cool.
All right, so let me get it open, I guess. Here. And so it's interesting because this was the first tool that I ever had to run this way, which is just, like do the dots. Oh, sorry, you are not even looking at my screen, right? So let me share my screen. So this is the first tool that I actually had to run this way. Obviously just go to the Toolbox folder, and then you just do the /toolbox to run the program, which I've never encountered that, but either way, besides the point. So what we're looking at here is this is the module for the CBC Casper binary. Is the size okay? Should I make it bigger? I actually don't know if I even can. It's okay. I'm not even sure how to. So I was saying there's kind of the three aspects. So we're in the TLA aspect here. There's also the model checker aspect, which I don't think I've generated any models for this, but basically you would just go like, oh, okay, I want a new model and do that. And then, it says there's 7 errors, but basically, and we'll get into more of this stuff, I guess, but basically the errors are coming from the fact that it's saying like, well, what is the model? You got to specify the values of your declared constants, and there's these 7 constants over here. So once we give all of these constants values, then there should be no more errors, as long as the specification is actually good. Hold on.
So when you say model, you don't think about state. You somehow with the model you are specifying values for your state, or this makes sense?
So with my, sorry, hold on.
Mhm.
Okay, sorry about that. So the state that you're talking about is, so the way that Lamport defines it is just the state is just an assignment of values to variables. So basically the whole idea is, so you see this is like, so, you know, okay, so model description, this doesn't do anything. It's just to like say what the model is about. Then you have this behavior spec, which essentially you have a few different modes, like either no behavior spec. And my understanding of why you would want to use this is, I'll just show you. So like no behavior spec would basically be, so you can go over to this model checking results and like enter some expressions here, like maybe you have some function called add and you want to apply that to 2 and 3 or, you know, whatever. And then it'll pop up a value here. So it's kind of like a way to interact with some of the functions and things in your model, but it has nothing at all to do with state. This is kind of external to all of that stuff. So that's my understanding of why you would want this no behavior spec. And I got that feeling because you have this option to select no behavior spec here in this field. Either way. So the way that they've set it up here is, so if you have a formula that's defined in your model called spec, it will by default just pull up in this format where it'll say the behavior spec is the temporal formula, which is called spec. And so somewhere in here, there's something called spec. So we can go and look at that really quickly if you want. Yeah. So here is the definition of spec. And so basically, the double equals is just like the definition of. So we're defining some formula. It's either you know, or really, you know, I guess maybe an expression. Okay, I'm not really sure on the lingo quite yet, but it doesn't really matter so much. But either way, this can say something about actions, or it can say something about the state, or both, or it can be a constant thing. But in this particular definition, it has a few parts. And so one of the weird things about TLA syntax is you can write kind of like a list of conjunctions, and it's basically like a bullet, you know, conjunctions or disjunctions. And it's kind of like a bulleted list, except the bullets are the conjunctions, if that makes sense. So basically this is like, I have one item and it's this thing, and then I have another item and it's this thing. And you know, equivalently, this could have been written just like this, and it would have meant the same exact thing. But either way, so
it looks like it looks like you say, oh, this is like parsing rules for grammar, and you know, you're saying the spec is the root or where I'm starting.
Yeah. And so, I don't know what that is. So specifically, this spec is made up of 3 different parts, and you know, they're all this conjunction of 3 different things. And the first thing is this init. This is like the initialization of the state, and so we can go ahead and find that. And here's like the definition of init. It doesn't really matter what it is, but basically it's just an assignment of values to all of these variables initially, right? Just like start here, and then so that's what init does. And this is just like, you don't need to call it init, but if you don't call it init, then you have to specifically tell it like the initial state is whatever you called it. But if you call it init, it will automatically know that, basically.
Oh, okay.
Yeah.
And
so
this end, is it sequential or like a parallel? Is this like ordering or?
So I don't know, and I'm not sure if it even matters, because this is like a logical conjunction. So the thing about it is, this is not a computer program. You're not writing a program. You're just writing a formal specification. So it's like, this is just, you know, mathematics that you're writing down. It's not executing in any way, basically.
Okay.
So my understanding is the model checker is doing something that's executing, and it's based on sort of what's written here, but this is not like a program in any way. And he says that several times throughout the lecture series. And I should put a plug in for that lecture series. It's really, really good. It's 10 videos. The first 7 are, you know, about 20 minutes. The last 3 are 2-parters, about 10 to 20 minutes each. It's fantastic. I mean, that's what I've looked at so far. That plus, you know, actually looking into some other people's specs. But I mean, he gets into all sorts of things like, so you see this like WF sub vars here. This is like a weak fairness condition to express some sort of liveness about this specification. And he gets into that, you know, weak fairness, strong fairness, safety. So essentially this is like your safety portion of the specification, and this is your liveness portion of the specification. And it'll get into the distinction about, you know, safety expresses like what may happen, and your liveness condition expresses something about what must happen. And he has great discussion throughout. I at least think he explains things in a really, really clear way.
And this is by Leslie Lambert, right? By
yeah,
right?
Yeah, exactly. Yep. Yeah, and he's really goofy. I mean, he does like silly things throughout the lectures, like so one thing that he talks about are so like what is a state, right? Like I said, it was an assignment of values to variables. So like for example, here, you know, you define, you know, of course, like what modules you're using, right? And so you just say this module I'm in like extends these things, so to like import all of the operations and everything you need from these modules. You define your constants, and then oh, it's strange. I haven't worked too much with the plus cal stuff, but this you know, like algorithm flag basically is indicating plus cal code. It's kind of weird because it's in a comment, like you comment all of the plus cal code out, and it does some weird like transpiling from the plus cal code you write to TLA plus. I haven't worked too much with that, but either way, what I'm looking for is something like this. But it's slightly different the way it's set up here, because this is in plus cal, and it looks like they're actually giving some initial values for things. But in TLA, you don't give initial values. Actually, let me just pull this up really quickly so I can show you what I mean. So something like this is what I'm expecting to see. So this is just purely TLA. And so you do some variables declaration, and then this basically, you know, it's like there's 5 variables here. These are the things that are meaningful if they change, essentially. And this is, you know, have been a really long explanation of how he's silly in the videos, but basically the point is that so these variables are the things that you care about the value of course. But his thing is that there are actually infinitely many variables. Basically, all possible strings are your infinitely many variables. These are the only ones you really truly care about. So you have to constantly tell TLA plus, like, I only care about these variables, because it's allowed to do these things called stuttering steps, which are basically like changes of the values of variables which you say you don't care about, essentially. And so, not to switch around too much, but let me go back down to the bottom of this because that was where it was important. So that's why you'll have an expression like this, because, you know, so this is like the like modal box operator here out front. It kind of looks like, you know, an empty list in Rolang basically. And then you say like, okay, so this is like, you know, the box operator, and then you're saying like box, the next transition, which is, you know, defined above, doesn't really matter what the definition is. the important thing is that you also say what variables you care about the values of. Because essentially saying this box with these variables is saying like you care if this thing happens or if none of those variables change. And so that's kind of like where this stuttering step business comes in, because you can change any of the other variables, or at least, you know, like the model checker can change any of these other variables that you don't care about. But when you declare something like this, it doesn't change these variables, and those are the transitions that you're really interested in.
Okay.
So I don't know if you have any questions about that, because I know I
so where these underscore vars are defined?
Yeah. So vars is vars is usually defined at the beginning, and typically, and again, kind of just like with spec, next, and init, to call the tuple of all of your variables, vars is kind of just like the standard practice, is what it seems like. But yeah, so here's where they have all of their individual variables, but they just put it in this tuple. For whatever reason, it's, you know, double angle brackets for the tuples, but that's just how it is.
And when you say underscore, what are you saying? Like
yeah,
connecting?
Yeah. So let's go back here. So here, let me separate this a little bit. So basically, this this box next underscore vars really just means box next. Whoops, a little bit differently, maybe in parentheses. Box next or you don't change any of those, which the way to put that is like unchanged, and then you would just say like bars.
Oh, this is like a syntactic sugar for
yeah, exactly. It's a syntactic sugar that somehow is telling the model checker, like, you know, what stuttering steps really are, because stuttering steps are when you change variables that are not these variables. And he gets into a whole discussion about why stuttering steps are important. And the reason, I don't remember exactly what his reasoning was, but I think it was something along the lines of you don't have full control of all of the changes in like a real system. So he wanted to somehow incorporate that in even the models. But like I said, that's my understanding of why these stuttering steps were important. Okay, let me get rid of that stuff.
Cool.
Yeah. Okay. Do you have any questions so far?
So hi, Kevin.
Yeah. Hey, Kevin. How's it going? All right. See you, Kevin. So yeah, you know, you have these temporal operators, of course. It's, you know, temporal logic of actions. So you have here's the box operator, here's the diamond operator, and you know, they mean what they typically mean in like modal logic. So this is like, you know, this is always in every state you can do these things, and this is like eventually this thing will be enabled essentially.
And when you have this next inside these brackets, this means inside the box, or this is just
no. So this is just the notation for if you're doing. So you can maybe I can go back and just show you exactly what I had before. So this is what that notation means. This just means like in any state you can take either a next step, or you can do something that doesn't change the variables that you care about, which is a stuttering step.
I see. So box and the diamond are always empty. Like, I mean.
Yeah, there's no context for them. Yeah.
Okay. Cool.
Yeah, exactly. Yeah, and you just throw it out front. Like here you got like diamond of, you know, some stuff here, which, you know, they kind of give you a clue as to what it does, of course, by calling this formula termination. But basically it's like eventually, so this backslash A is like for all, you know, like upside down A, if you've seen that. This is like for all things that they're calling self in this thing they call proc set. It satisfies this predicate, right? Like, I don't know what PC is, but apparently it's some function you're applying to this thing self, and that equals done, right? So it's like somehow it's keeping track of like what this thing is working on, I guess, I'm assuming from the name proc set, and you want to see that all of those things are done, right? So all of your processes have finished, I guess, and that's their definition of termination.
And this is this PC is like this represents the state and the self also. This is part of your state that you are caring about, right? You have it somewhere in variables, right?
So PC, yeah, exactly, is a variable, yeah. So yeah, and so PC.
Okay.
So the interesting thing about TLA is they don't make distinctions between things that you would make distinctions between, and by that I mean when you declare variables or constants, it's kind of assumed, unless you say otherwise, of course, that these things will all be sets. That's kind of like the default, is these things will be set.
Just wanted to ask you that.
Yeah, and you know, they don't have to be finite sets, because I don't think they imported it here. Oh, they did. So there's this module, finite sets, and like I don't know exactly what's in there, but I know two of the operations that you can kind of like extract from this finite sets module is you can, it's like a predicate. You can say like, is this thing a finite set, and you know, like true or false. And you can also get the cardinality of a set, and infinity is a fine cardinality to get out of a set. But of course, you wouldn't get that for a finite set, right? But in general, sets don't have to be finite, because you can basically define sets intentionally in TLA plus, which is you know, very cool, and what allows for a huge amount of expressivity.
Do you have maybe sample for that? I would like to see.
Do I have
what is the syntax?
Oh yeah, sure. I mean, so like integers are, you know, I can just write something here. So like integers are clearly an infinite set, right? Because when you think about the set of all integers, it's certainly not finite. So I could define a set, say like, you know, even, and this would be, let me try to remember the notation. I think it's just this. So then I can say like, I want all of the integers in integers. I don't remember if that's the right way to do it, but I think it is, such that, I don't know, how would I say this? I think there's a modulus operator here, but I don't remember how it's written. But either way, I'll just write it in like pseudocode, basically.
Okay.
So I would say like, you know, 1 mod 2 is equal to 0 or something like that. And this is like a fine thing to write in TLA plus.
Cool. This is like some kind of set comprehension, something like that, right?
Yeah, exactly. Yeah, it's like, yeah. So specifically, this is like set builder notation.
Set builder.
Yeah, but the really nice thing is like you can have, you know, say, I mean, and this is an infinite set. Like, so if I were to ask like, hey, TLA plus, what's the cardinality of integers, or what's the cardinality of even, it should tell me infinity for both of those.
Nice. It's not too hard. I mean, syntax is not too strange. So.
No, it's not. And you know, like I said, I'll repeat this because I don't know if that's the right notation. But for example, this is the right, like, you know, I is an element of the set of integers.
Yeah, this.
And let me show you this too, because this is super nice. You can go to this produce PDF version. Oh, whoops. What? That's weird. Okay, that's strange. I'll do it on this one because I know this one works. But you can go to the produce PDF version, and I'll give you like
nice.
be in the way. Yeah, it gives you like nice LaTeX, formatted PDF version of your definitions, which is great.
Mm. Oh, so this backslash is somehow from LaTeX, right?
Yeah. Backslash in is like there's got to be a notation in here. No, there's one. I just don't know how far down I have to go to get to it. Yeah, so like the equals turns into this equal with like the delta on top of it, which is like a funky notation for.
Oh, and this is a tuple, right?
What's that?
This is a tuple with square brackets, right?
So curly brackets is a set. So this is like a set with these strings as elements. So here's like your backslash A turns up as upside down A. So this is like equals turns out as that. Here you go. Here it is right here. So this is like backslash in turns into like, element of notation.
Okay, I see it now,
Yeah. Okay,
and maybe tuple. Do you have tuple?
Oh yeah, tuple is just like angle brackets.
Okay. Oh yeah.
Yeah. Yeah.
Okay. Nice.
Yeah. So I mean, that's more or less, and of course, if you have a universal quantifier, you also want an existential quantifier. So you got, this is like backslash, capital E, and that's your existential quantifier.
Cool.
Yeah, so that's pretty much it. But it's nice that it generates those things. So one thing that I wanted to show, I think I deleted it. Oh, but it'll be cool to reproduce, guys. So one thing that's cool is, so you can define your own functions, and so basically I have some functions defined here. This is not like particularly related to Genesis ceremony or anything like that. It's kind of just like general stuff. So I got these functions from so they have like pretty good documentation, pretty good resources on GitHub, and they have one repo on GitHub called community modules. And so in those community modules, they have, some more definitions of functions and these sorts of things. So like one of those functions is a function toSet, and it basically takes a sequence. And then essentially what it's saying is like, whatever elements you have in the domain of your sequence, which I'll explain what that is in a second and why that makes sense. You're just gonna, take like that ith element, right? So if I is in the domain of your sequence, you take the ith element, and that's basically it. And you have the set that does that. So this is just converting your sequence into a set. The reason that this domain of a sequence makes sense is because semantically sequences are just functions on 1 to n if the length of the sequence is n. So you can treat them as functions and like ask for their domain and that sort of stuff. But basically, so writing what I have here, hopefully that makes sense, right? I'm just saying like I want each element in this sequence basically, right? An equivalent way to write this would just be something like, I want every element and I is in the set from 1 to the length of the sequence is an equivalent way of writing that same thing.
Okay.
Right. And so there's this nice notation for like 1 ... to length of S. And this means, the set of integers from 1 to whatever length of S is. So if it's 5, then, 1, 2, 3, 4, 5 would be the set. Yeah.
So
let's can we pause a second?
Sure.
I wanted to welcome Kayvon. I don't know that he's been to one of these before.
Thank you. I haven't. This is my first. But I noticed Isaac put a put this on, and I've been interested in learning more about TLA plus.
Oh, cool. Yeah, I'm kind of just rambling right now. Maybe I'll say something interesting at some point in time. But thanks for joining.
But I do watch your YouTubes, so I can't always participate, but I do watch the YouTubes.
Nice.
Yeah, and Isaac is great for this kind of explanation. You know, I learned K framework just from Isaac's explanation.
Oh, good. Well, I learned too because it forces me to explain it to someone other than myself, which is always a good thing.
It's the best way of learning, right?
Oh, absolutely. Yeah. Yeah. Oh, hey, Steve. I think you just joined.
So I wanted to ask you, you're talking about functions, and you said this is not programming language. So why are you talking about functions?
Mathematical functions.
Okay.
Yeah, so it's not like given this input, here's the output. It's just a relation, you know. There's not a computation that happens associated with the function. It's just a definition of relation. If you like, it's just a set, because it's all a function really is, right? It's a set of pairs.
Okay.
Right, it's a set of two tuples that has a certain property, right? Like if you only have one output, or one output's the wrong word. You only have one element in the range for a one given input, basically, right? So like you know, like f of, you know, a is unique. There's not two values for it, right? Because that's like a general relation, is that you may have multiple values associated with a given input value. But I'm not going to be able to get away from the input-output language, but I think that's just the easiest way to explain it. But there's no like program execution that's happening, if that makes sense.
Okay, I see.
Yeah.
Okay.
Yeah. Oh, and so yeah, I mean, here's like an example of using this cardinality operator, right? So you have to import the cardinality operator from the finite sets module. So actually, these two definitions I thought were really, really cool, because I saw in Pavel's spec, he was using some function called set to sequence. He was using a function called sequence to set. I'm just using this two set. It's slightly different. And he was also using a function called map sequence, and that like mapped over a sequence gives you back a sequence, but you can just like apply a function to each one of the elements. But he was using some module which he called util, which I don't know what that is, and I haven't been in correspondence with him, so I don't have access to that. So my workaround was to just define it all myself, and so that's where this stuff came from. Oh, and I'll say something about the reason that I call none a constant here in 1 second. Well, I guess it basically says it right here. I needed options, and what are options? I mean, they're basically like you get a none or you get a sum of some data, right? Okay. And so the way that I modeled that was, you know, I have a constant which I'm calling none, and then basically my options are going to be, well, you can get an element out of this set of data, or you can get this none element. Either way works per fine. So there's no sum that you have to care about anymore. It's like you either just get the element or you get none, which actually simplifies some code, because then you don't have to say like, you know, dot sum of whatever it is you're looking at if the option is, you know, a sum option, whatever. I don't know if that even makes sense what I'm saying, but I think this is even simpler in some way. It's not like the conventional way to do it, but I think it's simpler. Oh yeah, so let me talk about these two functions because I think they're really cool. So we're defining this function is injective, and so they're defining it on S. S is a function. I have no idea why they call it S. Maybe instead of I'll call it F because I like that better. And so basically, so like, what is an injective function? I mean, it's a one-to-one function. So basically, it's like for each output, there's a unique input that gives you that output. And so basically what they're saying is like for all, every 2 elements, so this is, you know, for all I in domain F, for all J in domain F, this is like a shorthand for saying both of those things at the same time. You just say for all IJ in domain F. They're going to satisfy this predicate. And so the predicate is an implication. And so it's basically saying like if the output values are equal, right? If f of I is equal to f of j, then that necessarily implies that the input values are equal, right? Which is just like literally like you look in any math textbook, that's the definition of an injective function, and you can just like transpose it in TLA+.
This is very nice.
It's very
And
nice.
You're specifying property directly, right?
Yeah,
saying,
yeah,
okay,
exactly.
this. Oh, yeah.
Shouldn't
Yeah.
that be if and only if? That shouldn't be double error.
It is, and you get the other direction for free, right? Because if you were to put the same input value in, a function only has one value, so automatically you would have that one output value associated with each input value, right? So if we're already restricting our consideration to functions and not just general relations, then it's true. But yeah, you're absolutely right. It can very well just be if and only if, but I guess this is even less somehow.
And how can you use this injective function?
Oh yeah, great. I'm glad you asked, because that's the next one that we have defined here. So so I needed a way to convert a set into a sequence. And so like I said, a sequence is just a function. Okay, so I want to take a set and somehow make a sequence out of it. But you can think of, you know, okay, you have a set of n things, there are n factorial ways to make a sequence out of that, right?
Yeah, what is the order?
Exactly.
Yeah.
Doesn't matter. It's just a sequence from your set. And so this is a definition that says it doesn't matter, basically. So what this definition says is like, my definition of set to sequence, okay, let me take one step back. It doesn't matter because I'm not executing a program that calculates this value. I just need the specification for it. So it's really great. You get away with a lot of stuff because you don't need program execution. So either way, I don't really need one. Behind the scenes though, this choose operation here does select something from this allowable thing, but a priori, it shouldn't matter what element it's selecting. So like, I don't know what thing it selects, and it shouldn't matter when I use this. But either way, let me say what this actually means. Okay, let me tell you what this notation means. So we looked at this 1 to n, basically 1 dot n, just a set of integers from 1 to n. So we basically say like, what is the cardinality of this set S, right? I'm putting a set in here and getting out a sequence, hopefully, is the point. So I'm saying, what is the cardinality of that thing? If it's infinite, that's fine. This will basically be the natural numbers. If it's finite, okay, great. It'll just give me a finite set of, you know, positive integers from 1 to whatever that number is. And so I have a set on the left side. Clearly I have a set on the right side. S is a set. And so like this square bracket set on left side, arrow set on right side is the set of all functions from the left set to the right set. So this is saying f is some element of the set of all functions from this, you know, set of integers to whatever the set S is. Right, so domain is here, range is here. And the important thing there is that the domain is a set of positive integers, like finite or infinite, doesn't matter. But that's exactly what a sequence is. It's just a function whose domain is a set of positive integers, 1 to, whatever, consecutive integers.
So an example of that f could be a counting function.
Yeah, yeah, exactly. Yeah, an example. Yeah, an example could be like, my set is, A, B, C, D, or something, right? And my function f that I'm choosing in this case might be something like f of 1 is equal to A, f of 2. This is like the simplest one you could possibly think of. F of 2 is B, f of 3 is, C, f of 4 is D. But the point is, since I'm using this choose operation, I shouldn't care which one of these functions I get. It just will have the property that it is a function from this set of integers from 1 to the cardinality of S, and with range in S.
So I've walked into this late. I apologize if you already.
Yeah. That's okay.
Is injective is the function? Shouldn't there also be something about that the function needs to be onto, or surjective? I think it's the other name for it.
Oh, yeah. So functions can have different properties, right? And so injective is just one property a function could have. And so, like you said, surjectivity or onto-ness is just a different property that a function can have. But surjectiveness is based on the range of the function, and basically, it's based on the domain and the range. But basically, a surjective function is just one that touches every element of the range. Yeah. So it all depends on what you want to consider the range of your function. So, like, for example, I had this stuff up, right? Like, I can think of, this would be really goofy, but I can think of f as a function, and now this is not proper notation, like TLA plus notation that I'm writing here, but hopefully you'll understand what I'm saying. So f I can think of as a function from 1 to 4, and this could be, let me call this set S, and I could think of the output as just S, and of course that's totally true. Like, this function has this signature for sure. It also has the signature that you could, like, add some other element to it, E. The problem now is that this function f that I'm talking about is no longer surjective, right? Because it doesn't touch every element in this like codomain.
Right.
Yeah. So this is like a really contrived, goofy example, but this is what people are talking about when they say, like, a function being surjective as opposed to not.
But in this case, on line 27, shouldn't we also add surjective, since we want to consume the entire set?
Yeah. So again, I think it's just the case that you're going to get it for free, considering that we're taking as input the number, basically, 1 to the number of elements that are in the set. You're getting set elements as the output, and you're also specifying that it has to be a one-to-one function. So automatically, you're going to get that it's also onto.
Okay, I see. Yeah, I need to go through and see what I get implicitly and what I don't. Okay.
Yeah, right. And you don't even have to, say the implicit stuff, because it's really like, in this case, it was really important that this, and really just because here we're defining, injectivity, right? And so this is like, you were right. This is if and only if, but we get the backwards implication for free, basically.
Cool. Thank you.
Yeah, absolutely. Yeah, so just to reiterate what's happening here, right? So basically, we're saying we're choosing some function from 1 to the number of elements in the set, and that could be infinite in general. This I didn't put any kind of constraint on the set S itself, so it could just be integers, for example. So we're taking any arbitrary function from 1 to the number of elements, to those set elements, such that that function is injective, right? So that's what we need for us to take this set and make it into a sequence, right? Because like I said, a sequence in TLA plus is just a function whose domain is, you know, some like set of subsequent integers or consecutive integers, positive. Okay, so
and this S can be uppercase, lowercase, or why is uppercase?
yeah, I mean S can be, you know, whatever you want to call it, really. But yeah, so I guess like you know, these were essentially just copy and pasted from the community modules. They define it in this sequences extension. But you know, you try to make it suggestive. So like lowercase s is sequence, you know, or you could call it f because, you know, sequences are just functions anyways. And uppercase s is like set, just because that's typically how people would write it in like a math textbook or paper or something like that.
Oh, okay.
So one thing that I thought was really cool, that I haven't seen elsewhere, but is the case here, is so for example, I can let me just say I can define some function that's like I'll call it add. It's going to be a binary function, so it'll take some a and b, and basically what it's going to do is it's just going to add a to b, right? It's fine. I just define some binary function. Notice the very nice thing is I don't have to say anything about types of anything ever. It's great. It's really great because it's not a programming language. But either way, so okay, I define this function add, and it just takes two elements and it adds them. So
but when you say when you say plus, you know, you think about some types, right?
yeah,
what
definitely.
Can you
right?
Yeah.
So like this operation isn't going to make much sense if I try to put a set in here or a sequence or something, right? It's really only going to make sense when I put integers in there. But the nice thing is I don't need to worry about that as I'm writing the specification. It's only when I start doing model checking that it's going to make any difference. Either way, maybe it's not that big of a distinction, but I don't even have to write anything to enforce like a type checker. So one thing that I wanted to do is, I don't remember if this is the right way to say it, but so fold is kind of like I'm gonna take some. Oh, am I defining this right? Dang it! Now I'm having second thoughts, but let's see it through. Maybe it'll work. So I can. Oh, I don't want to define. Oh well, either way, let's just see if I can make this work. So basically, with a fold operation, usually you'll give it some you know, some function that you want to use as like the operation. You'll give it some initial value to start with, and then you'll give it like a list or something along those lines. So we can define fold for a function that has two, I think this is how I want to do it, that has two inputs. I don't need to say what they are. I'm just, you know, saying like the first argument in this fold operator is some two argument operator. So this is like a, you know, like a higher order operator. I need some initial value. So maybe I'll just call it, you know, like init. And then maybe I need a sequence or something. So I'll say sequence. And basically what this fold thing is going to do is, let's think of how I want to define this. So it's like for the first element, I want, and I'm going to need to declare this as recursive as well. And then I say fold, and I think I have to specify this. Okay, I think that's all I need. This is just to tell it that, you know, I'm dealing with a recursive function. So let me see how I do this. Yeah, okay, I think this is what I need. And then basically I'm just going to say, oh yeah, okay, I'm blanking on really easy things. So what I need is like, okay, if I'm looking at the first element, so like if I'm looking at, let me see, I think I need to say something like, if I'm looking at the first element, so just say I equals 0, then I'm not sure about how I'm writing this, but maybe you guys can help me. Then basically what I want to do is just fold on the rest of the list, right? Or sorry, use that as the first argument and then call the rest of the stuff.
So I think that's, I mean, I don't know about TLA, but when you do recursive functions, we're doing recursive functions on something that's inductive, right? Is there a way to represent S as inductive?
Yeah, how do you like destructure S?
How do I destructure S?
Because, you know, like we define the next element in S, like there is usually something that says if this is initial S, this is the next S.
Yeah. So I'm for this purpose, I'm thinking of S as a sequence, and so it's basically like a list, but semantically in TLA plus it's a function that has domain 1 to whatever the length of the list is, or the sequence.
I see. So we could assume there is a function that gives us the next element.
Yeah, and so so basically all I have to do here, I think, I'm just concerned about this condition, but we'll figure it out in a second.
Okay.
But all I have to do here is say, you know, what's going to happen to the initial element, and so I'm saying that with this, I'm basically saying like, okay, if it's, that's not all of it, right? I need another thing here. So this might be what you were talking about. So that's how I say, oops, that, right? So basically I'm saying if I, but it doesn't start at 0, rather it starts at 1. But either way, it doesn't really matter that much. Maybe that answers your question. If it doesn't,
yeah.
That okay, that's cool.
Yeah.
And so then otherwise, what I need to do, yeah. I don't think I need to be this careful, but I'm also gonna specify like that. Not and.
Yeah, you want to connect S and I, right?
Yeah. So here, how do I do this now? I'll write that in a second, but either way, I still need S and, maybe, well, this is the wrong thing to be thinking here. Let me just call that A, because it's not always the initial value, right? It's just like whatever value I had there. And then I'm adding the I element to that, and then I'm going to the I plus first element, right? Does that make sense?
Yeah.
So,
do you need to say that this I is related to S as some kind of how do you know this I is a part of the S? Just by definition?
Yeah, just by using it here. So automatically, when I say this, it at the very least it knows that it's a function, because this is function application. Like I'm applying the function S to the input I. And so I'm thinking about it as a sequence, but really I'm actually kind of defining even a little bit, well, not a little more general, because recursively it's only ever going to call then like the next integer. But
this can be a set, right? You're just saying that give me the next element, and
yeah, right, yeah. Yeah, but specifically, it would have to be a function because I'm doing the application here. And then I think this got way more complicated than I wanted it to. But I'll show you something where maybe it's like way easier to understand because I'm not fumbling over like what is the definition of hold. But either way, and then here, if I end up with an those are not the right things. If I end up with an empty sequence, so this is another indication of what structure I use as the third argument here. Is I have to tell it kind of like the terminating case or the base case or whatever. And so if it's the empty sequence, then really I just want to return A, right? Because I accumulate the value in that second thing. I probably did it wrong, but yeah, it doesn't like this. Oh, because when I use it, I don't need to specify the number of arguments, I think is the deal. Yeah. Oh, what isn't like about that? Oh, I think, oh, whoops. This is what it doesn't like. It still doesn't like something, dang it.
Why are you
Is
using
F equal maybe? If
Maybe
I equal
that one, come on.
in your if statement.
Yeah, here, well, so single equals is a check for equality.
Oh, okay.
And double equal is like definition of something.
Yeah.
Oh, dang it. And I don't need these here because I'm just checking equality now. No, come on.
Well, then there should be two equals on line 33, no? Oh.
Dang it. This should have been a lot easier than I made it. So yeah, I'm not seeing very, okay. My point being,
you said this is a syntax for tuples. So
yeah.
is there the same for sequence, or maybe you want to say
Yeah. Sequences and tuples are the same thing. The only other guess that I have without like really focusing much more is maybe I have to say that. No, it of course doesn't like that. Dang it. I am.
But it gives you feedback when you save the document, right?
Yeah, that's what it's telling me. It's
okay. Nice.
parsing error.
Nice.
So why is it saying it with the double equal here, but with the single equal, it's very different. I think the problem is that I'm forgetting how to correctly use this recursive stuff. And this is why I said, oh, we got into like a way more complicated example than I had hoped to.
And definition, the order of these definitions are
that might
important, or
actually you might be right about that. But now it says that, so maybe we can do that, and still doesn't like this one.
I have a non-syntax related question on this. I mean,
yeah,
this is probably just some syntax error that we could figure out, right?
Yeah, right. That's, yeah. I'm gonna comment this out. Maybe I can just.
So, in line 33, how does it know when it's reached the end of the sequence?
Yeah. So, oh, that's a good question. This is the wrong. I think that's actually the problem, right? So it needs to know that it reached the end of the sequence. Yeah, you're absolutely right. I think I need another if statement in here, maybe. Right, like
or start at the end of the, or just as equally, you could start at the end, like a full.
Yeah. Okay. So maybe then I should just start at the end of it. Yeah, I know I'm doing something really goofy right now. And then maybe what I actually want to do is then look at this. That's still good. Let me get rid of this because it's super annoying. And then here still should be the same thing. But then I need to say, yeah, it's not the empty sequence. This is not the, oh, hold on a second. Oh gosh, is this what I'm doing wrong? So I get to the last element and I just want to apply this to the last element. Is this what I need to do? Still doesn't like it. Huh. Okay, clearly I'm doing something wrong. The problem is that I really haven't used this recursive thing before, so I'm just messing up the syntax. Okay,
something as a homework.
Yeah, seriously, yeah, figure that out as homework. Gosh, this turned into like 20 minutes, but what I really wanted to do was, all I wanted to do was show you that you could define these higher order operators. So basically, like, in such a way that you can actually tell it, like, hey, the fold operator is going to expect some binary operator, basically, by using this kind of syntax. And so, like, I was unsuccessful in producing a real example, but
well, you know, seeing errors is also very useful. So
yeah, I guess that's true.
so,
so
you know, maybe so sometimes I learn more just from errors than you know, for successful stuff.
Maybe then I can also do something like this, and let's just say that, and then dang it, don't know what I'm trying to do here, but maybe I want to like tell it that it's gonna accept this multiply operator here, and then take two things, and then give me back, oh, I'm still definitely not doing this right. Crap. Yeah, this is not super interesting, but I'm just like blanking on the right way to do it. So maybe I can just say something like this, and the point being here. Are you serious?
Oh, you want to define this with this underscores, right?
Yeah.
As some kind of variable.
Oh, this might be the issue in this case. Now I need to tell it. Oh God, are you kidding me? Okay, I am clearly messing something up, and don't know.
Do you need? I mean, you're using existing function, right? Yeah.
Yeah, I need to do that first. Oh my goodness. All right. Wow, I'm really sorry about that. And then what I want to do is say something like, oh well, I don't even need to write this here. So okay, great. It saved. It parsed. Perfect. Don't worry that this is the Genesis ceremony spec. It doesn't matter. What I need to do now is so now to like work with this stuff, right? So what is the point? I know I just spent like 30 minutes trying to do this, but the point is that you can define these higher order operators in such a way where you know, if you want this thing, which I called, you know, mult1, to accept some binary operator, you do it by this, and then you just say like, well, how is that binary operator kind of like used in this particular operation? And so I'm essentially saying like, I'm going to feed you an operator, a binary operator, and then two things. And so maybe this is just like, I'll call this up, because now I have two options. I can do it with add, or I can do it with multiply, right? And so so here's the thing: is I can open up a model. Yeah, it's got some errors. It doesn't matter. So we got to move this.
And you can easily define flip, right? If you want to flip arguments, you can easily define, right? You just say binary function, yeah, AB to BA, and
yeah. So I can go ahead and just say like, don't worry about any behavior spec. I just want to, you know, use this operation with add. You know, I mean, this, like I said, this is totally goofy, but you know, I want to do this with like 2, 3 or something, and then you can not press enter, but go ahead and crap, I really need to specify those values. Okay, well, I'll just tell it that it doesn't really need to know what these are, and and we'll move on with our lives, and hopefully I'll finally show you that this evaluates to what you want it to. Oh my goodness, there it is. All right, cool. So basically I told it run model checker with no behavioral specification, and so like actually compute this value for me. And so then, you know, once it goes to actually compute values, obviously it is executing some program, but the specification itself is not saying like how the program is executing, which is very nice. And then of course I can use my mult operator in here as well, which is gonna multiply them and give me state, of course.
Yeah, nice. So you're saying this expression is evaluated every time you start model checking, because there is no behavior specification.
Yeah. So I'm saying no behavior specification because I don't want it to do anything more complicated at the moment. I really just want to evaluate this expression, right? So, and the reason I wanted to do that, oh, this is cool. I didn't even realize that. But the reason I wanted to do that is because I defined this operator, which took a binary operator and 2 inputs, and then applied the binary operator to the 2 inputs. And I just wanted to show you that you could actually evaluate the expression to get a value out of it. Yeah, and so one thing I'm curious about, because I haven't messed with this before, but like you said, like there has to be some sort of types, right? So like what happens now? It complains, of course, but oh, can I get this out of the way? Dang it. Oh, that's weird. Oh, here we go.
Okay, this is clearly the problem with types, right? You have 2 different types, but if you have 2 strings, 2 and 3.
Yeah, if you have 2 strings,
this maybe makes sense.
Still doesn't like it. Yeah, and I
because,
don't.
Yeah, it's an integer. Yeah, okay.
I don't know that there is like a string concatenation operator in TLA plus. I don't think that you know, method or operation or whatever is exposed to you. But certainly you have it with integers, right? As we saw by doing this, because I just called, you know, that op thing with multiplication, which is, you know, just the way I'm writing this name here. Oh, wow, I didn't realize this is kind of cool, actually. You can just hover over it and it'll tell you like it's kind of like a signature almost for the operator and a signature for the multiplication.
And it's not only signature, you see the whole thing.
yeah, right, like the actual definition of it, right?
Yeah.
That's pretty sweet. I didn't know that.
So for what purpose is this expressions? I said you don't have any behavioral specification, so you have this expression executed, but I don't see how this helps you if this is just, you know, printing something. There is something else, right?
So the only thing that I've used it for is to make sure that I'm defining things properly. Like, so I will use it to just like do a little test or something like that, you know? So the reason that I encountered this stuff, which let me comment all that out. I don't know if there's a better.
Expressions are not part of the specification, right? They are part of the model checking, right? They have.
Yeah. So I mean, well, these guys are part of the specification, but basically, you know, like I literally just wrote these in. Clearly, I'm not using these functions anywhere in the specification. But actually, there's probably a better way to answer that question, and I'm not sure, but certainly they're being used in the model checker. Yeah, and so the reason that I needed something like this and why I had to look into all of this stuff was because there's this so this is like a state transition. It's called broadcast stream. Basically, you're given some message, which you don't even really need to know what that is. It's just it doesn't really matter. You're given basically a sender of the message and a set of recipients for the message. So it's like you want to broadcast. So whoever I am, I want to broadcast this message to like this whole collection of validators or something. And the way that I'm going to do that is basically I'm going to, well, first start off by defining some functions. So there's like a let something, you know, be equal to whatever in a particular expression kind of syntax, which is really nice. And so basically it's like you got this function create packet, and it's going to take just an element of the set, which is not clear by the way that I wrote it here. But it becomes clear by this, you know, call to this packet function, or sorry, this pack function, which is defined up here. Again, doesn't really matter what the definition is, but these are going to be like just an individual value, not like a set of values. And one other thing that we hadn't talked about yet that is now going to come up is, so this n outstream message, again, don't worry about what it means. It's a variable though. And this little tiny prime right there, so I said n outstream message prime, basically means like this is how this variable changes from the state I'm in to the next state, right? Like I'm defining a state change. This state change is defined by changing this variable. And currently the way that it's written, it's not explicitly only changing this, well, it's explicitly only changing this variable, but it actually allows for other variables to change. And that's why when you actually use this broadcast stream, you're also going to use something like this unchanged operator here, which is basically to say like, well, the other variables are actually not changed, and that's now a valid transition. Like you can go ahead and change this outstream message variable, but don't change anything else, kind of. And so it's not clear here because it's just like building up a function to use somewhere. So this is like a state transition function, basically. Oh, and so here's some other strange but useful syntax. So it's saying, okay, the new value of this variable, outstream message, I know new value because of the prime. The new value of that variable is equal to this stuff here in the square brackets. So square brackets don't have anything to do with functions or anything like that in this case, even though they do in general. It's saying the new value of that variable is equal to the value of the variable, the unprimed version of the variable, except we want to change one single component of this thing. So this thing is a sequence or a tuple, however you want to call it. They're the same in TLA plus. Except it changes this one, you know, like argument or whatever, and it changes it to what's written here, right? So it's going to change it to whatever the old value was for that given, you know, like component or whatever. And this is like some weird notation for append for like a list, but it's a sequence. And then
is it the same for set and for sequence, or can be used for?
Is what the same?
Is the same?
No. Is what the same?
This append, is it the same for set or for sequence?
Well, so there's no such thing as append for a set because sets are unordered, but sequences are ordered. So with a set, you know, the analog of append would be a union, which is this /cup.
Oh, okay. Oh,
yeah.
You showed this. Okay, yeah.
But here, basically, what it says is like the only, you know, part of this variable I'm changing is this one coordinate, and I'm changing it to the old value. But I'm then and this old value is a sequence. So apparently this thing is a sequence of sequences. Doesn't really matter. But I'm changing that sequence in this coordinate to be whatever the old sequence was and append this new sequence of things onto it. And that new sequence is basically like take each one of the recipients in that twos set. Oh crap, this looks horrible. Take every recipient in the twos set and create a packet to them, basically, is all it's saying. Right, so like I'm gonna take like each one of the recipients individually, create a packet from me to that recipient. That's my new packet. I'm gonna you know, do it as a set. That's where the curly brackets are coming from. But then I'm just going to turn that set into a sequence. And the reason that I can do that is because I don't really care what order it's in. I just want these messages to all.
Okay. And why are you using sequence and not just set if you don't care about ordering?
Yeah, so so we're using sequences because my understanding. So this was all set up from Pavel's work. So this is me just like to understand what he was doing here. And my understanding of why you want this to be a sequence is because you're kind of modeling a queue. So there's like an ordering to like, I received these messages in this order kind of. And of course, this is not like received messages, but this is like messages I'm sending out, and you can't, you want an ordering for the message that you're sending out, because like, okay, I'll send this one, then I'll send this one, et cetera, et cetera.
I see.
Isn't it more about that you could have duplicates?
Sorry, what was that?
It's not formally a set because it can have duplicates.
Oh, so this will not have duplicates because, like you said, it's a set, and for a few reasons, right? Like this _2s is a set, so there's no duplicates there, and I'm just taking elements from that and then creating a unique thing for each one of those elements, right? Like the message is the same, but the message packet is different. Because the packet also includes like the sender and receiver information. So each one of the receivers is different for each one of these packets that's created, if that makes sense. Oh, you're muted, Jim.
Yeah, that's. I misunderstood what it was. Thanks.
Oh, yeah, I know. I mean, it took a while for me to explain it.
And how do you not lose ordering? I mean, you're working with only when you do this append, you're saying, okay, I will convert this to sequence.
Yeah. So this goes back to this function that we talked about earlier, the set to sequence function, right? So it's going to choose an ordering, but for all intents and purposes, it's arbitrary. It's just some injective function from 1 to whatever the size of the set is to the elements in the set. I don't care. Just give me an ordering and we'll roll with it. It's
you can
basically
think of it as an indexing function. Just give me
yeah, exactly.
But you will always get the same ordering, right?
No, it depends on what function you choose, right?
That's right. And so in general, the ordering shouldn't matter if you're using a function like this. It shouldn't matter what function I get. The way that it works semantically is it's always going to pick the same one. But when you use an operator like choose, it shouldn't matter which one is being picked, if that makes any sense.
Right. You're abstracting over that in that function. Whatever.
Yeah. Right. Exactly. Just some injective function with the right domain
properties.
Range. Yeah. So that's pretty much it. I mean, that's that seeing this well, and the way that Pavel had it was a little bit different than I have it here, but semantically they're equivalent, because he did something quite strange where well, either way, it doesn't matter. He was doing a mapping over a sequence, but it was strange because he already had this set, and then he turned that set into a sequence and then mapped over that sequence, instead of just like mapping over the set like I'm doing here and then turning that into a sequence. I mean, tomato, or, 6 1/2 dozen or whatever, but, semantically it's equivalent. But either way, the reason I ended up doing it this way is because I didn't need to define an extra map sequence function to do that. So I felt like this was the easier of the two options. Yeah, it's getting to be about the time where I have to head out. I feel like maybe I should say some kind of like concluding remarks or something. I don't know. Do you guys have any like outstanding questions or something?
Just one. This underscore in arguments in these functions.
Yeah. You mean like
this? Is just yeah. You just want to say this is like not global variable, right? Something
Yeah,
like that.
yeah. So he uses it up here too. So he's got like, here's my variable underscore message, and basically I think it's to, you have a variable, it's to indicate, you know, okay, and so like, for example, this, the output is a record, right? And so a record in TLA plus is just a function whose domain is the string, well, in this case, MSG, the string from, and the string to. But either way, so what it's doing is basically just saying like, okay, this first variable is going to correspond to the message field, the second one to the from field, and the third one to the to field.
This is like a named sequence or named tuple, right?
Yeah, or function. You know, it's a record, right? So yeah, I mean, you just call it a record. and you know, the reason that I was asking you that stuff about Scala actually was because in looking at this code, well, we can see some of it. Like, so for example, the way that you access, you know, like say something from this to field is you have something that is just an element of, okay, yikes. Again, this thing here, even with that n in square brackets, is a tuple because this outstream message, n outstream message, is a tuple of tuples, right? So n gives me access to the tuple in the nth coordinate, and then head, of course, does exactly what you would think, gives me the first thing in that tuple that I now have access to. But the things in those tuples are these packets, right? So they're records. And I want the receiver of that particular packet. So I need to access the to field. And so I basically say like, okay, head of the tuple I want dot to, and that gives me the stuff in the to field.
And of course, if you have records inside the record, right?
Yeah.
Inside one record, in one field, you have another record. You will have two. Oh yeah, you have this.
Yeah, yeah. So for example, something like that. Yeah. Yeah.
Cool.
Yep. Yeah. So I thought that was cool, and it made me feel like I understood Scala a little bit more, but I don't know.
Yeah.
I don't know if it really helps, but that's pretty much all that I have, I think. Oh, one other thing, just because I'm looking at it, it's very strange, but not equals to is written as a pound sign in TLA plus. I've never seen that before. You could do it like that, or you could do it like that. But you know, I'm in favor of less characters, so there we go.
Okay. This other is similar to Haskell, so.
Oh, okay. Okay. Yeah.
Nice.
Yeah.
Thanks.
Before you go away, what was your comment again on where we started talking about the most disruptive change?
Yeah. We started talking. Okay, but you got to give me more information than that because I don't remember what my comment was.
Yeah. Well, I guess it was composability is what he was presenting as that.
I didn't watch that stand up.
As soon as you make a smart contract, let's say on a theory.
Yeah.
Okay, you've broken it because you're putting something into a system which may be correct, but what you're putting into it may not be correct. Okay.
Sorry, I remember my comment now. I think it was about the specifications implementing one another. So, I mean, correct me if I'm wrong, but I think what you're asking about is what I said about, so I'm going to, the plan is write a TLA plus specification for CVC Casper in general, because you know CVC Casper is constructed in such a way that you automatically get consensus safety, and so then the goal is like, okay, once I have that, great, I automatically have safety. It says nothing about liveness though, And so then when you go to RChain's implementation of Casper, if I can show that the model, at least on a high level, right, on like an abstract level, if you can show that the TLA plus specification for RChain's implementation of Casper actually implements the specification for CBC Casper, you automatically get the safety for free for RChain's implementation because it implements the specification properly. Liveness has to come from somewhere else, and that's what the synchrony and fairness business is about, as far as I understand. I know at least the synchrony, and I think the fairness plays a role there too, but I'm not 100% sure. But
they will also be a part of the same specification, right?
Yeah, exactly.
Okay,
right.
Okay.
Yep. Yeah, and so but that's okay because the safety and the liveness properties are kind of separate in a sense, and that goes back to what Leslie Lamport talks about in terms of what a model may do and what a model must do. And basically all you need to show that a model specifies, or a model specification implements another model specification, is that the behavior that the one that implements the other may do is kind of like contained in the set of behaviors that the other may do. I don't know if I explained that well, but point is, I think, okay, so I don't have like a mathematical proof of this, but I think it's more or less intuitively clear that if I can show that RChain's consensus implements CBC Casper's consensus, I directly get the safety from that. Liveness is still a separate issue, but hopefully, the plan is to address that in the TLA plus model as well.
Right, but he was more or less talking about behavioral type things, like in principle, if you try to put something into RChain, which was I don't know. It's I guess the composability proving of the applications on RChain as opposed to the Casper itself. Now, is Casper Labs doing the same kind of protocol validation as we're doing? I mean, they have these theory files, PHY files.
I don't know, honestly. I'm not very familiar with their project. I just recently saw that Medium post that I put in I think I put it on the RChain public channel, and then also on the Colab consensus channel about their they have a specification for and proof for liveness and safety for their implementation of Casper. But I haven't read their paper. I mean, they have a paper, and I guess what I was saying at the beginning and before we recorded is I was expecting them to have something like a TLA plus spec that had those proofs in it, but that's not what I saw. So I don't know. Maybe it's buried deep in there, but
yeah, I just saw the links you posted, and
yeah. The layer X stuff looks really cool too. They have they're using like Isabelle higher order logic. I don't know if those are the same or if those are different things, but they're using those proof assistants to prove some of the properties of CBC Casper, which sounds really interesting. Again, I haven't looked into it all that much, but it seemed cool.
Awesome, thanks.
Yeah, oh, absolutely.
Thanks. That was great.
Boy, hopefully I'll have more stuff to tell you about it regarding TLA.
I have a quick question, Isaac. Can you?
Yeah.
I'm just starting on this. I noticed there is a tutorial on the TLA website. Is that how you started, or do you have any
Yeah,
other
yeah.
advice?
I think I still have it open. Where would it be? Here? No, this is the paper. Oh, this is the book. So Simply Lamport makes this all freely available. His Specifying Systems book. I have not read through this book. You can see it's almost 400 pages. This is like the resource to look at.
Okay.
There's another one written by this guy Hillel Wayne, and it's called Practical TLA Plus, something along those lines. I can put links in Colab if you guys are interested.
Oh yeah, that would be awesome, especially
yeah.
to this,
Yeah,
just so I can.
Oh yeah, and the videos. Yeah, I don't have it up currently. I don't know where I put it. But yeah, it's on the TLA Plus website, and it's just the video lecture series. It's
Perfect. Cool. Thank you.
Yep, absolutely. Yeah, I'll put some links in there. All right. Yeah, I think that's basically all I have.
Okay, thanks. Thomas, did you have comments on the most disruptive feature? You were part of that. You were part of that discussion, right?
Yeah, and you mentioned this verification of protocol or Casper, right? But we want to have this for every smart contract that is deployed on normal production, right? So this is for me the most disruptive thing, right? So not only that we will have some code which is verified, but each user who is using ArchChain will have a verified code. So yeah.
Yeah. You have to hold on, Michael. I'll be with you in a minute. Yeah, I'm just finishing up another meeting. So if I were to, if you were to ask me what's the most disruptive feature of ArchChain, and that it implements a world computer constrained by the process calculus, would be my answer to that. Now, I don't. Yeah, I guess you have to then prove that that's the way to make a computing network, reliable and predictable, and I don't know. It seems like that that's the really unique thing about ArchChain, and it's what it doesn't seem to be emphasized when they compare ArchChain with other systems, whatever. I don't know.
Yeah. I was a few days ago. I was on blockchain meetup here in Zagreb, and I was listening about Z-Starks, and this kind of stuff. And the message was, why would I put all my data on the blockchain? The reasoning is I will use some kind of I will save this off-chain, and I will hash it, and I will have this snarks or starks proofs. But again, then the problem is you don't have this data on the blockchain. So now you have the problem. Where do I put this data? Is it decentralized, or So this is not the solution. I don't see this as a solution. I see just another way of looking at the same thing. So and then talking about the whole behavioral view on this whole data or managing this data. This is I'm not sure that everyone thinks about that. So
wait, can you say how? So you said you didn't see the snarks and starks stuff as the solution to this not wanting to put your data on the blockchain. So are you making a comparison to how our chain is handling the issue? Maybe I didn't understand the distinction there.
So yeah, they're talking about this way of like a solution for sharding.
Yeah.
So you will
Okay.
have your off-chain data, and
Okay.
you will have proof that you did some computation on your off-chain data,
Yeah.
your off-chain
Okay.
state.
Mm-hmm.
But you know, then again you have blockchain, then you have something else.
Yeah.
Then the question
right.
is, okay, what is this something else? You know,
Mm-hmm.
so yeah.
Okay. Okay. Cool. Yeah, I didn't make that connection to sharding and that sort of stuff.
You know, the key thing to me is that you shouldn't have to. I mean, you know, for practical purposes, we don't want to know what the something else is.
Yeah.
If you look at the work being done on the peer DID, peer DID documents,
Yeah.
they're sort of homeless, decentralized identifiers. Okay, they're not on the chain. They're not anywhere. They have. It's, you know, it's protocols, not platforms. Okay,
Yeah.
so
I mean, that's the thing, right? When Greg is saying, okay, we have these different protocols, different languages, but we need something like a Rolang that we can express everything. And we can definitely have different languages for different things, and somehow, you know, we will manage this and say, okay, we can, you know, it's not perfect.
Transpile it to Rolang or something.
Yeah, but if we have Rolang, we have everything. We have query language, we have storage. So
you see,
that's the ultimate specification.
the way I see it is that, you know, everyone runs their own shard. They have their own node. Every community has its shard, its nodes, and then we have, you know, we have the global art chain. We have a fully decentralized network, and you know, the stuff that I store on my own node doesn't have to, you know, exist on the other the community nodes or the global node. I think that's ultimately what we need. Okay, is that, you know, that fractal hierarchical system, which is totally scalable.
I mean, we want that today, right? With the file system, we have this kind of key value store. We have the name of the file, and then the value is the file. But we don't have programs. We have data. We have key values and we have data, but we don't have programs, and we don't have programs as the keys. That's the thing.
No
Our keys, yeah, there's no reflection. So if we have these two things, that's the main thing.
Yeah.
So I've been thinking of an idea, and I don't know if it really makes sense, but when you guys were talking about you know, having like the ability for each user to verify their contracts before, you know, like deploying them or whatever. So, you know, obviously I've been working with like TLA plus. I did like deep immersion in TLA plus. So now everything I see is like, oh, how is this like TLA plus, you know? And so I'm thinking like, you know, Rolang is a specification language. Like, could we build something like a TLA plus that uses Rolang as the specification language? I don't know about the model checker, but we also have this like proof system that's associated with it. So it's almost like the same kind of suite, but like, you know, hosted from Rolang. I don't know if that makes sense though, or like what the value add is for something like that. So I don't know. I just wanted to
yeah. I mean, I'm thinking about this is the same way. I mean, I understand Greg exactly like that.
Yeah, yeah.
And we have this tuple space as a model that we are checking.
Yeah,
right?
or
because
maybe
we have.
Is Rolang already what I'm describing?
Yeah. Greg said that the tuple space and the Rolang they can be extracted one from another. So it's
Yeah, right.
they're the same.
And then we look at, you know, secure systems and, you know, Mark Miller's Jesse, which, you know, if you look at the Jesse code, you know, for makement and
That's
wow,
the ERTP stuff, right?
what?
That's the ERTP stuff that
Yes.
that you were talking about before. Yeah. Okay.
Right. Jesse is a subset of JavaScript that,
Oh yeah. Okay. Right.
for, you know, for defining these safe algorithms, network algorithms. So,
Yeah.
you know, I mean, you know, looking at the Jesse implementation of makement and the R-chain implementation of makement, it's, you know, like
It's very similar.
we could do the Jesse, we could do Rolang very close to Jesse if we're, you know, just follow some certain basic rules.
Mhm.
You know, it can do the cross. I mean, we could do the cross-chain safety and.
But in
Sure.
this simple example, yeah, it's very similar. But when you take a look how this is connected to multiple chains, right? In watts, so they will accept other programs from users, and they use secure JavaScript to evaluate this. So they have some kind of reflection, but I think they will discover a reflection, you know, as they are developing the system, and they will they will definitely discover, you know, rolling as something that is already done the whole thing, you know, because now they are saying, okay, we have a val function, but we have a sandbox environment, and this is exactly what Greg was explaining. Having sandbox environment is not enough. So yeah, these systems uses sandboxes.
Yeah, you know, the notion of, you know, a channel or a name. You know, can be decentralized, and that's all that has to happen in order for us to.
Yeah, but I don't think this is the main question. The main question is how these channels are described. Do you have like a rich language for these channels, or do you have just, you know, URLs and they're just
Right.
I mean, in ERTP they are objects.
Yeah.
But
and we have.
Hey
the
guys,
whole
it's been
language.
super interesting. I gotta get going though. Sorry.
Bye, thanks.
Yeah, thanks for listening. Thanks for your comments. I'll see you guys next week.
Yeah,
So,
I'm afraid I have to drop off too. Thank you very
See you
much. This was a learning thing for me.
bye-bye.
Okay, well, stop and, you know, Golang is our data language. So if we standardize on that, then everything will be meaningful. See ya.
Yeah.